In this video, I want to go over some of the math skills that you need to remember to have a successful year in Algebra 2. This list is not exhaustive, but it should address the background knowledge that you should have going into any lesson or any quiz. In another video in my channel, I address some of the algebraic common mistakes that I have seen in past quizzes. Between this video and that video, if you can keep in mind the suggestions, perhaps watch the videos again prior to any quiz or test, it may help you perform better. Let's get started. Since Algebra 2 comes after Algebra 1 in geometry in Texas, I want to identify skills from both classes. From Algebra 1, you need to remember the three major properties of operations. Other skills that you need include solving equations and inequalities, solving literal equations, dealing with domain and range, whether algebraically, graphically, or definitively. Also, Algebra 1 is basically 60% about linear equations, so you need to recall concepts that deal with graphing lines, identify characteristics of lines. Algebra 1 also is about 20% focus on quadratic equations, whether you're solving them, graphing them, or factoring them. In the next few slides, I will just briefly review these concepts. I may add additional videos to the channel later to go in depth on some of these concepts, so please be patient with me. These three properties are important to use whenever you want to simplify your expression or your answer. You have learned them throughout middle school. The commutative property basically just says you can interchange the order when you're adding or multiplying. 4 plus 7 is the same as 7 plus 4, though this isn't true for subtraction. And 3 times 5 is the same as 5 times 3, and this isn't true for division. So adding and multiplying are kind of special in that they share this property. These two special operators also share the associative property. You naturally do math operations going from left to right, but for these operators, they can also be done right to left as well. Not shown here is the property also works for subtraction. However, the property does not work for division. And the last property is pretty well known, the distributive property, and people typically don't have issues with it. Okay, moving on. One of the skills that you learned in Algebra 1 was how to solve inequalities. Recall that inequalities basically is comparing two things, in that one side is less than the other side. To solve an inequality, you have to isolate the variable, whether it's x or y or whatever the letter is. You will have to use the three properties, along with some other properties under the order operations, aka PEMDAS. And in your last step, you have the variable or the letter by itself on one side. The next topic is solving literal equations. This is probably one of the hardest concepts for students in Algebra 1 to learn. Solving any equation, which by the way, the definition for an equation is basically something equals something else. The one ingredient that you need for any equation is an equal sign. That is why it's called equation or equation. In literal equation, you literally have several variables in the equation. Some equations have x, y, and z in it. Some equations have y, m, and b. And the evil ones have all 26 letters in the alphabet. In solving equations, you're asked to isolate one of them, and sometimes that requires jumping through some hoops. Here we have a reminder of what domain is versus what range is. Domain is the set of all x values, and range is the set of all y values. A function maps your input to your output, your x to your y's. In other words, a function is a rule that depends on x and it results in y. You plug in an x value and you get a y value as output. That's why x is called the independent variable and y is the dependent. If you ever get confused which is which, Think of this metaphor. On the income tax return form that parents filled out every year, parents are classified as independent because they earn money for the family. Kids, on the other hand, are classified as dependents because they depend on their parents. Here's another metaphor. Your parents, mom and dad, are X values, and together you are their output, their Y value. And sometimes they are more than one output. But then family is not a functional family anymore. Okay, this metaphor is falling apart, but I hope you get the point. Okay, we're past the 5-minute mark, so I'm just going to speed through the rest of this PowerPoint presentation. You also learn in Algebra 1 how to graph your x and y values onto a two-dimensional grid. Basically, your x corresponds to the run of the graph, and y corresponds to the rise. X affects the horizontal position, and y affects the vertical position. Your reference point is the origin at 0, 0. In Algebra 2, you'll be doing a lot of graphing. This slide is probably the most important slide because it represents a big chunk of this Texas STAR test. If you're familiar with the 3 major forms of linear equations, how to solve them, how to identify the slope and other characteristics, how to graph them, and how to manipulate one form into another, then you can answer enough questions to pass the STAR test. Recall also that in Algebra 1, you compare 2 lines or more. Okay, quickly, just a reminder that parallel lines have the same slope. So once you identify the slope value of 2 lines, then you will know whether they're parallel or not. And to tell whether lines are perpendicular or not, their slope values must be negative reciprocal of each other, shown in the equation on the bottom right. Next topic, factoring. It is a process where you take something and make it look like a product. In other words, you rewrite an expression as something times something else. This concept has many sub-lessons, and you will learn a lot about it in Algebra 2. Your success in this class and in all future math classes will depend on your ability to factor correctly and to factor quickly. That and avoiding silly mistakes on order operations. Here in this slide, I just show a couple of examples on factoring that you may have done in Algebra 1. Example 1 is done by factoring the GCF, greatest common factor, and example 2 is done through guess and check, aka trial and error, but you can also do example 2 by using the AC method. Okay, this next part you may or may not have learned it in Algebra 1, but don't worry, in Algebra 2 you will learn how to graph quadratic equations. Quadratic equations also have 3 major forms, like the 3 for linear equations, but they are a lot more involved in finding characteristics of quadratic equations, which have a U-shaped graph. Again, don't worry if you didn't learn anything about graphing quadratic equations in Algebra 1. It's just that if you had this first pass of this information already, it will give you a leg up this year. But you know, factoring is part of quadratic equation lessons, so you should at least have learned that. Finally, in Algebra 1, you should have learned the quadratic formula. Learned it as in memorized it. Make sure you remember all of the formula, not just part of it. Oftentimes, I hear students recite the formula to me, but whenever I ask what is the first part of the formula, a lot of them cannot tell me. And what I have always reminded them is that the first part is actually the most important part. So what is the first part? It's x equals. By recognizing you're solving for x, then you understand the whole part or the whole point of the quadratic formula. The other techniques to solve quadratic equations include factoring, completing the square, and the square root method. Okay, changing gear. Let's talk about what skills from geometry you need for Algebra 2. Well, there aren't too many that carry over, so that's the good news. But you should know the general equation for a circle, and you should know the general formula for parameter, area, and volume for various shapes. Here is the general equation for a circle. The h, k are coordinates for the center part of the circle, and r represents the radius, how far from the center to draw the circle. Here are the formulae for the parameters, the areas of some common geometric shapes. For a circle, we don't use the word parameter, we use the word circumference. And the formulae for the rectangle and parallelogram are actually the same, but just things are relabeled. Here are the formulae for the volumes. We have a cube, a cylinder, a cone, and a sphere. Okay, so these are the main concepts that you should review prior to that first week of school in August. Good luck and have a great year.